Okay, we are back with Learning with Mr. Neff. And today I want to talk about I can solve systems of linear equations using elimination. Now we've talked about three different methods to solve. Really, the first is graphing. You see, graph two things, two lines, and where do they meet? And that's the solution. Substitution, plug into one, and then you'll be able to solve for the other and figure it out that way. And this is elimination, saving maybe the best for last. Reminding you, a system of linear equations, typically we're going to deal with two equations here. It can be put in the form y equals mx plus b. So that's our system. And like I said, we're using elimination, which is probably my preferred choice to go with. Okay, so right here now, we have an equation here. You can write it down, take some notes, or follow along. But the idea of elimination is sometimes it's called multiplication addition. Now, we're not going to do any subtraction. You see books do subtraction. All we do is adding the opposite. We don't do subtraction, so we're going to do all adding. Now, looking at this, elimination is the idea of getting rid of one variable. Now, I can add on the left side, I can add what's there, and on the right side I can add what's there and it still be equal. See, how can that be? Well, can I add 5 on the left, 5 on the right? Sure, because it's equal. Can I do that with 10 and 10? Sure, it's equal. Well, we're saying this is equal, so on the left I can add it, and on the right and still be equal. So we're going to go ahead and add this, and we're going to see good things happen here. 3x plus 5x is 8x, and then right here, this is it gone. All right, that's 0y. It gone, it's disappeared. Therefore, you have all you need. You have 8x equals 16, and to save us time, because we can solve that, x equals 2. Normally I'd show you more work, but I just want to get the basics of this down because I know you can solve that. So then we take the 2 and we plug into one of the equations. Which one, Mr. Neff? Well, whichever one you want. If one looks easier, do that. Now I'm going to plug in 3x plus, oh no, I don't want to do x, I want to do 3 times what I already know x to be, 3 times 2 plus 4y equals negative 22. Now, I'm actually doing this video again, true story, because even though I knew the answer, I solved it wrong because I didn't drop my negative down. So now I'm going to subtract 6. All right, 4y equals negative 28, and therefore y equals negative 7. All right, therefore, alright, that's my solution. But I'm going to use the check, and I'm curious on the check page if I did this right. Okay, so yep, there we go. What I did is I plugged in on the top one. I plugged in 2 and negative 7. Do I get negative 22? Well, I have 6 plus negative 28. Does that equal negative 22? Sure does. Alright, over here then, I got 10. Right, 5 times 2 minus 4 times negative 7. So minus a negative or plus 28. Does it equal 38? Sure does. Discount double check here. We got it. And that works. So that's that first example. Now the second one here, I'm not going to be checking all of these because I want to just show you the examples, and then you hopefully can figure out the check through the first one or already know how to do that. So this one now, if I add 3x and negative 2x, I get 1x. That doesn't cancel out. And if I add 12y and negative 4y, I get 8y. That doesn't cancel out. And so I really would like, them to line up a little better too. I'd really like to find a way to get these to cancel out. So if there's only a number that I could possibly multiply or do something there that would help me, well, there is. So if you look at the y term, I can multiply one of these equations by a certain number, and I'm in business, and that number is 3. Alright, now I'm going to rewrite the top equation up here. This is one of the organizational things I think is important. Rewrite it at the top like this, and then underneath it I'm going to write the other equation. I'll put it in blue just to throw you off. 9x minus 12y equals 51. And at this point now, I can add both of those equations, and good things are going to happen. You'll see. I'll go back to red. 7x, and then this gone, it gone, so say bye-bye to it, equals 21. Divide by 7, and x equals 3. Okay, so now I have that. So what am I going to do? I'm going to go to one of those equations. I'll pick the bottom equation. So I'm going to solve that original equation right here. So 3 times 3 minus 4y equals 17. So I'm going to solve for y. 9 minus 4y equals 17. Subtract 9, I'm running out of space. So negative 4y would equal 8. Divide by negative 4, and y would equal negative 2. So my solution is the ordered pair 3, negative 2. Questions? Oh, I don't hear anyone. Okay, great. Must have explained it really well to you. Alright, and the third and final one, to just keep rolling here, trying to speed this along for you, is this one right here. And so this is the granddaddy of them all, so to speak. This is what you if you can do this one, you can do the other ones, alright? So if you notice, I have a problem here, because 2 and 3, I really can't just multiply some 2, because 2 is not a factor of 3. And so in either of these cases, nothing's going to really happen. So what I want to do is actually multiply the top by something, and the bottom by something. I've got to be really creative with this. So let's look at what I can do to get rid of my particular x term. I think if I multiply the top, and you'll see, by negative 3 and the bottom by 2, good things will happen. What am I really trying to do? I'm trying to get a 6x and a negative 6x. So I multiply the top by negative 3 and I'll get negative 6x plus 9y equals 36, right? Positive. And then on the bottom, when I multiply by 2, okay, I get 6x minus 4y equals 4. Alright, so I had to multiply the top and the bottom by a number. So first one, I didn't have to do it to any. The second one, I do it to one of them, and now I got to do it to both. And so now I can add, and good things are going to happen. What's going to happen? I'm going to have that gone. It gone. I have 5y equals 40. Southern twang coming out a little bit. 5y equals 40. Y equals 8. So that's done. Not right quite yet. So then pick one of your equations. Really doesn't matter. The bottom might be a little bit easier to solve. But so I'm going to take 3x minus 2 times 8. And then that equals 2. So I'm going to solve that. 3x minus 16 equals 2. You can run out of space. So 3x. I'm going to add 16. Normally I'd show that step. And so I get 18. And then x would equal 6. So the solution to my system, and I can check it in both, is the 6, 8 is the ordered pair that satisfies this right here. Again, if we get the variables canceled out completely and it's a true statement, that's the other thing that maybe I would want to share with you, then if you're just left with 5 equals 5, that's infinite number of solutions. If you're left with something like 5 equals 0, that's false. That's no solution. Just a reminder there. So I think that's about all I got time for today. So I hope you enjoyed learning with Mr. Neff, and I hope you have a terrific day.